Hey everyone. In this video, we're going to be looking at Avogadro's law, which is the comparison of volume and moles. And so when we're looking at volume and moles, we're assuming that temperature and pressure are constant. And then the concept here is if you have more moles of gas, they're going to occupy a larger volume. Makes sense, right? More molecules of gas take up more space. If we start from the combined gas law, and we assume that pressure and temperature are constant, we can eliminate pressure and temperature from the equation because they're not changing. So our expression simplifies to V1 over N1 equals V2 over N2. And this is Avogadro's law. Let's do a practice problem with it. If 0.75 moles of helium gas occupies a volume of 1.5 liters, what volume in liters will 1.2 moles of helium occupy at the same temperature and pressure? So because temperature and pressure are not changing, we'll use Avogadro's law. V1 over T1 equals V2 over, V1 over N1, excuse me, equals V2 over N2. N1 is given in the problem here as 0.75 moles. Volume 1 is given as 1.5 liters. N2 is given as 1.2 moles. And the final volume is what we're trying to solve for. So let's take our expression. Let's solve for final volume. If I multiply both sides by N2, it cancels, leaving us V2 all by itself, which is what we want. V2 is equal to N2 times V1 over N1. Now we can plug in our numbers. So N2 is 1.2 moles. Volume 1 is 1.5 liters. And N1 is 0.75 moles. Moles cancels, so we're left with just units of liters. Makes sense because we're solving for a volume. So volume 2 is equal to 1.2 times 1.5 divided by 0.75 gives me 2.4 liters. Which makes sense, right? If we increase the number of moles, we should be increasing in volume. And so we went from 1.5 liters to 2.4. Makes sense. And it looks like we solved it correct. The next thing we're going to talk about is standard temperature and pressure. So chemists came up with this concept to have an agreed upon temperature and pressure at which to conduct experiments and record data. That way there's consistency. And so we define standard temperature and pressure, or STP as it's abbreviated, as 0 degrees Celsius and 1 atmosphere, or 273 Kelvin and 760 millimeters of mercury. So if you have a problem that says at STP, they mean 273 Kelvin and 1 atmosphere. And so another concept is molar volume at STP. And 1 mole of gas is always going to occupy a certain volume at a certain temperature and pressure. And for standard temperature and pressure, we can calculate this molar volume. So let's start with the ideal gas law here, PV equals nRT. And we're going to solve for volume. So if I divide both sides by pressure, volume is equal to nRT over P. And now we can plug in our values. We're talking about 1 mole of gas, so N is simply 1 mole. The ideal gas constant here is 0.0821 liters times atmospheres over moles times Kelvin. And temperature, because we're at standard temperature and pressure, is going to be 273 Kelvin. And the pressure at standard temperature pressure is 1 atmosphere. If we're paying attention to units, moles cancels moles, atmospheres cancels atmospheres, and Kelvin cancels Kelvin. And we're left with liters. Makes sense because we're solving for volume. So if we plug this into our calculator, 0.0821 times 273, we get 22.4 liters. And so this is the molar volume at standard temperature pressure. 1 mole of any gas occupies this volume at STP. And so it doesn't matter if we're talking about a mole of helium or a mole of oxygen or a mole of nitrogen gas. Any gas, as long as there's 1 mole of it, occupies 22.4 liters at STP. Let's do a practice problem. What volume is occupied by 2.75 moles of nitrogen gas at STP? Well, we just figured out that there's 22.4 liters per mole of a gas. So 2.75 moles times 22.4 liters for every 1 mole of gas. And we should get 61.6 liters. And it looks like we did it right. Let's do another practice problem. What is the volume at STP of 4 grams of CH4? Now, the trick here is they give us grams of CH4. In order to calculate volume, we need moles. So we have to convert grams into moles. In order to convert grams to moles, we need to factor in the molecular weight. And so from the periodic table, we know that carbon has a mass of 12.01 grams per mole. Hydrogen has a mass of 1.008 grams per mole. And there are 4 hydrogens in our molecule. We got to multiply that by 4. So CH4 should have a mass of times about 16.04 grams per mole. Now, let's convert 4 grams into moles. So 4 grams times 1 mole per 16.04 grams. Grams will cancel. So 4 divided by 16.04 gives me 0.25 moles. And then we can multiply this by our molar volume of 22.4 liters for every 1 mole of gas. It's 22.4 liters for every 1 mole of gas at STP. Moles cancels. I get about 5.59 liters. Let's see if we did it right. They rounded to 5.6, but yeah. So to recap once again, Avogadro's law compares volume and moles. Starting from the combined gas law, we can simplify our expression if pressure and temperature don't change to V1 over N1 equals V2 over N2. And standard temperature and pressure are defined as 0 degrees Celsius and 1 atmosphere. And the molar volume at STP is 22.4 liters. Thanks for watching, and I will see you in the next video.